This call is now being recorded.
Okay, so this is your January 2023 paper 1. And I think this kind of paper contains what? 10 questions to 12 questions? 12 questions in maximum. Okay, this one contains 11 questions. So very easy to do in that case. So we're going to start from the initial question. First one is talking about the chapter 2, right? Elastic plastic behaviors, everything. The first one says to describe what is meant by elastic behavior. This is actually a repeated question. Well, repeated question means because the definition for the elastic behavior would never change, right? So this will always be same. So if you want to describe this, that if you remove, if we apply a force on that plastic material, so on that elastic material, it will obviously deform, but the deformation will be temporary. And by the moment you remove that force, obviously the object will return to its original shape. So we can describe this that material has the ability to return to its original shape when applied force is removed, right? Only writing this will give you the 2 marks. So I'll write down the answer that material that has the ability to return to its original shape after the applied force is removed. If I want to highlight the mark scheme words over here, ability to return to its original shape, that is for 1 mark. And when force is removed, this is another mark, right? So these are your 2 marks for which you're going to get the marks for this question. I would suggest memorize this kind of descriptive questions, okay? Now moving on to the next one. It says that the material obeys Hooke's law. Hooke's law means what? That means over here, applied force is directly proportional to your extension, right? And if it's directly proportional, that means if I'm going to plot a graph, the graph will be a straight line with constant gradient and will pass through the origin. So over here, they're only asking you this, that sketch a graph for this material to show that it obeys Hooke's law as it is stretched. And you should also label both axes with appropriate physical quantities. I can understand that in this situation, the x-axis is going to be your extension. So I'll write, okay, this is my extension. Extension is measured in centimeters or meter. So I'll write measure in meters, unit will be meter. And on the y-axis, we have force, that is Newton. And as they are directly proportional means I'll check for these things. If they have constant gradient or not. Constant gradient can be represented by a straight line on a graph. So that is represented by straight line. And then again, if the graph is starting from the origin or not, origin means at every point the x-axis and y-axis will have equal value. Okay, that's why starting from the origin is very important. So must start from origin. That ensures that at every value y is always equals to x. And then again, lastly is your it's a straight slant line, right? The final answer is going to be under these 2 criteria. The final graph is going to be a straight slant line. So whenever you want to draw any relationship which represents what is this directly proportional relationship, then obviously they will always have a straight slant line. So a straight slant line. I hope you guys remember there are other 2 types of graphs also, right? Amra, can you tell me what is the other 2 types of graph that represents the relationships? Amra, can you listen to me?
Oh, sorry, Miss, I was on mute.
Okay.
Displacement time graphs, velocity time graphs, and acceleration
No.
time graphs.
No. I was asking the relationship graphs. Like this type of graph is for constant, directly proportional graph, right? This is one relationship. What are the other
Yeah.
two types of relationship graphs?
Um,
Relationship graph means that if two quantities are connected to each other, that means, or if two quantities are related to each other, right? They must have
yeah.
they must sharing a relationship between in between them. So one is this the one that they are directly proportional. For them, you draw a straight slant line passing through the origin, right? That is a y is equals to x shape. This is x-axis and this is y-axis. Then the other is y is inversely proportional to the x-axis, right? In this case, what should be the shape of the graph for inverse relationship? Amna, can you please turn on your mic?
Yes, miss.
What should be the graph for this inverse relationship graph?
It should be a curve.
Curve, how, what type of curve?
The exponential graph.
Exponential decreasing, right?
Yes.
Okay, so this is going to be exponentially decreasing, and we always have to make sure that this type of graphs do not actually, intersect with the x-axis or y-axis. So this is your y is equals to e negative x graph. Okay, the shape of, if you want to labelize this type of graph under the mathematical name, then this is e power minus x graph. You don't need to know that actually, but otherwise this one explains inverse relationship. Amra, is this clear?
Yeah. I just have a question. Will
Yes.
the graphs that such as y is directly proportional to x squared, will that be graphs like that as well?
Yeah, if it's a y is equals to x square, 1 minute. In that case, y directly proportional to x square. In this situation, it will be a quadratic equation, right?
Okay.
It will be a quadratic equation. In most of the cases, this is y is equals to directly x square only. Then it will be a quadratic equation passing through the origin. This is how the graph will
Yeah.
look.
Okay.
And then the last one is a non-linear relationship graph. Okay, for the non-linear relationship graph, 1 minute. I'll just take this to any of the closest blank space because this is quite important. This is your x-axis and this is your y-axis. And the last one is a sorry, no, this is actually also non-linear. But if you focus in most of the cases, this kind of questions or this kind of graph will be given that we're only focusing on positive x squared, right? Not on the negative x squared. So in that reference, you get a graph of this way, right? Only the half of that curve you're using. That's why this type of y directly proportional to x squared is also known as a non-linear curve, a non-linear graph. Okay, so this expression can also be explained as non-linear graph. And the last one is your linear graph. The difference between linear graph and a directly proportional graph is that directly proportional graph will always pass over the origin and linear graph will never pass over the origin, right? So this is your linear graph and this is your non-directly proportional graph. So these are your four different types of relationship graphs. Is there any problem from any one of them?
No, miss.
Amna, do you have any problem?
No, miss.
Okay, then we will quickly move on to the next question. We are actually done with this first question. Now we will move on to the second one. This is about what? Electromagnetism, right? Or maybe what? Yeah, electromagnetism. We need to add labels to diagram 1 to show poles of the bar magnets. Amna, can you tell me that depending on the direction of your field lines, which one will be the north pole, which one will be the south pole?
The way the arrow is pointing is south because
Sorry,
it always goes from north to south.
okay, so which one is north?
The left hand one.
Left hand one. Okay, so this is your north and this is your south, right? Obviously you use the basics that Field lines always move out of the north and enters the south, right? So this is your correct answer. Then the bar magnet are made from steel. Give one reason why steel is a good material for making bar magnets. Because steel are magnetically hard material. Okay, there are two types of material. I mean, in not exactly two types. These are known as, like, induced. Not exactly induced. These are mostly known as, like, electromagnet stuff. Like I provide. Yes, Amra, you can ask.
Miss, I'm not sure if my answer is right, but if it's one mark, could I just say steel is an alloy which contains iron? Is that fine?
No, this is not going to be an answer over here. Alloy of steel, or just because of iron got oxidized to become steel,
Yeah.
these are not the proper answer. The answer over here is that obviously they are not naturally magnetic material. We have to understand them, right? Steel naturally is not a magnetic material. Iron is not a naturally magnetic material, but you can make them behave as a magnet by using electricity also, right? These type of materials are known as induced magnetic material or electromagnet in some cases. Now in this case, if you're talking about a soft iron, that is just the pure iron is a soft magnetic material. So if you're talking about, okay, pure magnet is a soft magnetic material. Why is it soft? Because this will only be able to hold onto that magnetic materials as long as you supply electricity to them. The moment you cut off your electricity supply, obviously the soft iron core will lose its magnetism. So that's why they are known as soft magnetic material. Soft magnetic material means they can only hold their magnetism as long as they have a electricity supply. As soon as you cut off the electricity supply, that magnetism also, they also lose their magnetic properties. And now if you're talking about hard magnetic material, that is steel, these are the opposite of soft magnetic material. They are hard because over here steel will be able to hold their magnetism or hold their magnetic properties even when you cut off the electricity supply. So even I obviously have to use electricity to first make them magnetism, or first make them a magnetic material. But after they have gained the magnetic material or magnetic properties, if I cut this electricity supply after that, they will never lose their magnetic material, or they will be able to hold on to that magnetic material for a very long time. That's why they are known as hard magnetic material. Is this clear?
Yes, miss.
Also, another thing, under the notes section over here, I can see that allows steel keeps its magnetism. Magnetic material allows steel is hard to demagnetize. In the note section, they're accepting that we can allow that steel keeps its magnetism. But again, they're not considering this that as alloy of steel, which is made up of iron. That will be not mark scheme word for physics. That could be a marketing word for chemistry, but not for physics. So I'll write that because it is a magnetically hard material. So they can for a long time. Okay. Then I can explain how diagram 1 shows a uniform magnetic field. What do we understand by uniform magnetic field is that all the field lines are of equal distance with each other. They're all parallel to each other, and the field lines are all straight, right? They should not be any curve or something. So these are the three important points about the uniform field lines. So you should, again, this is a repeated question. This is a repeated question. But the definition of steel being a hard magnetic material is always going to be same. The properties you check in order to identify if any set of magnetic field lines are uniform or not, they're also going to be same. So these are two repeated questions again. So we can write that field lines are straight, evenly spaced, and parallel to each other. and parallel to each other. Okay, now after this, is there any problem till now?
No, miss.
Okay, then after this, over here, they're saying that diagram 2 shows a metal wire being moved downward towards the uniform field between the poles of the same bar magnet. The orientation of the magnets have not changed. That means this is still the north pole, this is still the south pole, right? So field line was still moving from the north pole to the south pole, and in this situation, this wire was pulled downward. That means a force of F Newton was acting on the wire in the downward direction, and we need to give a reason why a voltage is induced between the two ends of the metal wire as it moves between the poles of the bar magnet. Like over here, when you push this wire in between the field lines of the bar magnets, why a voltage will be induced over here? This is what this is your induced voltage, right? Induced voltage means that whenever a conductor is in motion inside your field line, obviously a voltage will get induced across the wire or across the conductor, right? That was the concept of according to Fleming's left hand rule. If you remember, whenever conductor is in motion inside a field line, obviously a EMF will be induced, right? Electromotive force, that is a voltage, and EMF will be induced across the wire. Since they're only giving you 1 mark, so I'm not going to write about all these things. I'll just write that because the wire cuts the magnetic field lines perpendicularly, and that induces an EMF. Is this clear? Any questions till now? Yes, Amra, you can ask.
Miss, could you also say the motion causes a change in the amount of magnetic flux linking with the coil?
Linking with the coil, magnetic flux. Problem is magnetic flux is not accepted. I mean, that will be a different property which we will learn in A-level physics, but I don't think that magnetic flux, we can write that in our mark scheme.
Okay.
Right, but the concept is same again, right? Because obviously there is a movement of the conductor for which there will be a change in momentum, and that creates a change in magnetic flux, which is correct, but our mark scheme will not allow it.
Okay.
So I can actually, I mean, I have the mark scheme actually. I'm sorry, I didn't send you guys the mark scheme. I will send you guys the mark scheme right after the class. Okay, so you can also see
Okay.
the mark scheme that not only just check for the answer section, also check for the notes section, like if your answer is getting accepted in somehow or not. So over here, the general answer is that because the wire cuts the magnetic field lines perpendicularly. Which induces an EMF. No need to write according to Fleming's left-hand rule and all, because for 1 mark I have already wrote 2 points over here, so no need to write about that. What was that? Fleming's left-hand rule and everything. This much is enough. Again, this is also a repeated question if you understand. Like the idea is always same. Whenever there is a motion of a conductor in between the field lines, the answer is going to remain same. The conductor cuts the field lines perpendicularly. According to Fleming's left-hand rule, obviously a voltage will be induced in that conductor, right? So the answer is again same over here. And then this one is also repeated question, as you can understand. State two changes that could made this arrangement that could be made to that arrangement increase the magnitude of the induced voltage. If I want to increase the magnitude of the voltage, then there are several options, right? I can use stronger magnets because stronger magnets have more field lines that will create more cutting of the wire with magnetic field lines and eventually increase the voltage induced. So that is one option. I could move my wire faster with a higher velocity. If I move my wire faster with a higher velocity, in that case again more field lines are getting cut per unit time, and obviously that will increase the induced voltage. And lastly, we can say that we can move the magnets closer to each other, right? If the magnets are closer to each other, again they will produce larger forces on each other. For larger forces, field lines will also increase in that case. And lastly, instead of using a piece of wire, we could have used a coil, right? Because a coil increases the surface area, that increases the number of cutting, and eventually the induced voltage over there. So there are a few points that we can write. First one is that moving the wire faster. I'll write down all the options so that you can use it in your answers. So move wire faster. No need to explain the reasons over here, though. You just have to like state the changes only. No need to explain that why that change will increase the induced voltage. That over here, the move the wire faster, and then move magnets closer, or use stronger magnets, or turn the wire into a coil or a solenoid. Or a solenoid, use stronger magnets. And then what? Use stronger magnets and move the magnets closer, right? Okay. Is there any problem from question 2 so far?
Miss,
Yes.
I'm just asking for one of the options. Could you say increasing the rate of change of magnetic field?
That is one of the reasons that, what can you change in order to, wait 1 minute. What was your question again? Sorry, repeat again.
Like for one of the answers, could you say increasing the rate of change of magnetic field?
But how can you, I mean, that will be overall idea, right? That
Yeah.
you have to increase the rate of change of magnetic field lines cutting with the wire. That will
Yeah.
increase induced voltage. But what do you have to do in order to increase that rate of change? Right? I mean, the
Yeah.
explanation that you're giving, that is the explanation, or that is the reason for which the field line is supposed to increase. All of these changes will increase the rate of change of your field lines getting cut with the wire. But the change that you have to take to the arrangement or make on the arrangement, these are the changes. They're talking about the changes that you can do in order to increase the rate of change of field lines cutting with the wire, right? They're
Yeah.
not asking you for the description that why the voltage induced would increase in some cases. If the question was like this, that why would the induced voltage would increase in some cases, then you will have to write down that, okay, the rate of change or rate of change in magnetic flux linkage have increased. That causes the higher, that induces a higher voltage. But over here, they were not asking for the explanation, or they were only asking that what changes you can do to the instrument to create that higher voltage.
Okay.
Okay. Amna, do you have any question? Amna, are you in class?
Yes, miss. Sorry, I had a problem unmuting my mic. No, miss, no questions.
Okay, thank you. Then we will move on. Now, this one says that a winch is used to pull a truck along a horizontal road, and the winch is connected to a truck by a thick rope. The winch does 41 joules of useful work on the truck when the truck is pulled by a horizontal distance of 15 Newton, right? They are asking you to write an equation for work done, force, and distance moved. In this situation, what do we have to do? We have to write down an equation. And always remember, I know I will write down the equation in terms of symbols as F W is equals to FD, but they will not give you a mark for this. Over here, whatever word they have used, always try to use that word only. Sometimes in the notes section, they will apply or they will allow this type of word equations or this type of equations in terms of symbols, but sometimes they might not allow that also. Just for the safety part, do not lose this 1 mark. We will write down the entire quantity in whatever word they have used. Work done, force, multiplied with distance moved. Then after this, we need to find out the force over here that the rope exerts on the truck. They have given you the value for the force, but this isn't, so they have given you the value, sorry, 1 minute. They have given you the value for the energy, which is work done, and they have given you the value for the distance also. Only difference is that energy is in kilojoules. If you want to find out the force, you have to always break down that kilojoules into joules. So you're going to first break down that kilojoules into joules. 41 kilo means 10 to the power of 3, if you remember. So this is 10 to the power of 3 joules. You have to understand these type of wordings. Kilo is 10 power 3. Mega, capital M, is 10 power 6. Milli is small m, that is 10 power minus 3. And then lastly that you have work with, you might have to work it with is micro. This is the symbol for micro, and this is 10 to the power of minus 6. Like opposite of mega is micro, opposite of kilo is milli. That means over here, this is your energy. Energy is given as what? Force into distance. Distance was 15 equals to 41, 10 power positive 3. And finally, force in that case is 41, 10 power positive 3 over 15. How much is this then? Try to calculate the value, please.
Uh, 2733.33.
Okay, 2733.33 Newton. Problem is in this kind of equations, sorry, the data that they have given, 41 joules, 15 meter, right? They were always in two significant figure. And if you're going to write your answer in six significant figure, that would mean that your answer is more accurate than the data used in the question, which is completely wrong because your answer was calculated using the given data. And your answer could never be possibly more accurate than the given data. That's why for this kind of cases, you should always stick to the significant figures used in the question. Okay. Since in the question they have used two significant figure, I will also have to use two significant figure, that is this much Newton. Is this clear? Any questions so far?
It's clear, miss.
Clear, miss.
Okay, now after this is a Sankey diagram. I think in the last class also we were explaining how to draw Sankey diagram and I couldn't draw that because of less space. Now they're saying that the winch includes a small engine. The engine burns petrol to power the motor in the winch, and the winch transfers energy mechanically to the truck. The winch has an efficiency of 25% while pulling the truck. Draw a Sankey diagram to for this energy transfer. Efficiency of 25% means what? That means out of the 100% input energy, the winch is only able to transfer 25% of that input energy into useful energy. That means the rest of the energy is wasted, right? Over here, this 41 kilojoule was the useful work over here they have given you. That means from there, you have to use percentage to find out the total input energy. In this equation, what we are using, we are trying to find out the total percentage, and they have given you the input value. So we're going to use this idea that I want to find out the input energy. For that input energy, I have, for the input, this is actually how we create the equation for percentage also. For that input energy, that represents the 100% of the energy, right? And useful energy is 25%. So I'll write 100 over 25 multiplied with that 41,000 joules. In this case, if you calculated 100 with 41 into 10 power 3 divided by 25, that leaves you with 164,000 joules. That means now again, if I want to find out the waste energy, like how much energy was wasted to the surrounding, that is 164,000 minus 41,000, and that gives you 123,000. Right? Okay, now using this 123,000, this also is your important information. After this, obviously, we'll have to do some scaling here, right? For that scaling, since I don't have much space, so this is what? Draw a Sankey diagram for this energy transfer, right? So 1 minute. For this scaling, we have how much? 41,000, then 164,000, and 123,000. I will represent them on my diagram as 41. Yeah. Um, Over here, I will be using, I will be dividing everything with 20,000. Okay, so if you divide 41 with 20,000, you get actually 2.05. So 2.05 to two significant figure will be 2.1 centimeter. 164,000 divided by 20,000 gives you 8.2 centimeters. And then again,
Miss,
120.
how do you work out the scaling?
Over here, I actually do not have any specific fixed value. Okay, I can
Yeah.
take any number. I can take any
Okay.
any random number and then divide my. But I have to make sure that I'm dividing all the data with the same number.
Okay.
And then again, also I will try to make sure that the lengths are quite moderate. For example, over here in your exam paper, actually you will have much space to fit in 8 centimeters and 2
Yeah.
centimeters. Right. So these are quite equal length or even length that you can actually measure or fit in this space. But maybe if you are getting like 20, 15, those type of lengths you would not be able to fit in. So that's why I try to use any number that gives you a moderate number, like 5,
Okay.
6, 4, 3, 2, 1, 2, or maybe 1 also, that is acceptable. But if you're also getting very small data, that means maybe 0.002 centimeters, how would you measure that, right? So you should
Yeah.
use any number that gives you a quite easy numbers to measure the Sankey diagram with.
So is there a range of answers for Sankey diagrams?
Yes, obviously they will always. I mean, that to be
Okay.
honest, over here the range of answer. I mean, they do not have any acceptable range. They're going to match your answer. That if your scaling matches with the diagram or not. You
Okay.
always have to obviously draw the scaling on side of your of your maps.
Okay.
So I'll write it down over here. And again, do not write on this section. I wrote it there, but you cannot write on the outside section. After this, last one is going to give you 123 divided by 20. That gives you 6.2 centimeter. Now over here, if I want to draw the graph or draw the Sankey diagram, I cannot take measurements here because I do not have scale here, sorry. But for that, 1 minute. Over here, you have to understand that this useful energy was using very small part of the energy, right? Most of the energy was actually wasted. 25% of the energy was actually used and 75% of the energy was actually wasted here. This is your 25%, and then a curved part to represent that 75% is actually getting wasted here. And in this case, you have to obviously write down that this arrow represents how much energy. This arrow represents that 41 kilojoules of energy, right? This arrow over here indicates 164 kilojoules of energy, and that one is your input energy. And this arrow over here indicates waste energy, and the value for this waste energy was 123 kilojoules. waste energy, and this is your useful energy. Is this clear? Any questions over here?
It's clear, miss.
Okay, then if we move on, over here there's a chart they have given, and it says the winch can also be used to pull the truck uphill at a constant speed. That means it can also pull the truck on an inclined plane with a constant speed. The table gives some energy stores. Add one tick to each of the row to show what happens when to the energy in each store as the truck is pulled uphill. That means we have to convert the change in energy over here. In general cases, what is actually happening? This is your horizontal ground and this is your uphill ground. If you're going to pull something above this inclined plane, that means obviously at the very end and at the very edge of this, at the very starting point of this journey, right? At this point, this is your total kinetic energy. Total kinetic energy at the very end will be converted to your gravitational potential energy, because at the final case you are h meters above the ground, right? That means obviously all kinetic energy got converted to gravitational potential energy. Over here, if there is a friction, so then again some portion of the kinetic energy will be used to overcome the friction also, so that will be a work done against friction, right? So if I have to explain, like in this scenario, it says chemical store of petrol in winch. Obviously the winch is providing energy in the form of by burning the petrol, right? So as it is burning the petrol to move that truck uphill, or even without the truck, if the winch wants to move the move itself uphill with that engine, that means obviously the engine is burning fuel. If the engine is burning fuel, the fuel amount, the volume of the fuel is decreasing. Eventually the chemical store of the petrol in the winch is also decreasing. So chemical store in the or chemical store of petrol in winch is decreasing, right? Because it is getting, the fuel is getting used up. The volume of the fuel is decreasing, so less volume is there present to carry out for the chemical reaction to release chemical energy. And again, gravitational store of truck, gravitational potential energy they're talking about, gravitational potential energy is going to increase because obviously after the entire journey, after moving through a hill or moving up a hill, the truck will be h meters above the ground, above the horizontal ground. So height increases, gravitational potential energy also increases. Kinetic store of the truck, as your truck is moved or truck is dragged up the hill, obviously that kinetic energy got converted into that gravitational potential energy. That means kinetic energy in that case decreased. So kinetic energy decreased because of friction, right? In this case, what happens? Because of friction was there, obviously as you're going to move this truck uphill, friction will act. Because of this friction, work was done, right? And what type of energy will be lost because of that friction? Because of friction, heat and sound energy is created. That means this is actually a wasteful energy over here, because my main intention was to make this truck move up the plane, right? So my main intention was to convert all the kinetic energy into GPE, but obviously because of friction, some of the energy was lost to the surrounding in the form of heat and thermal energy. So in that case, thermal store or thermal energy to the surrounding will increase. Is there any problem?
Miss,
Mhm.
I had recently got this question in like test paper,
Mhm.
and
Oh, I think that
according
is
to the
kinetic
marking,
same, right?
yeah, it
Yeah,
says
sorry.
stays this, but I don't get that point.
Okay, kinetic energy over here for the truck is same, because to be honest, the truck is not the one with the engine, right? The winch is the one with the engine. That was your trick over here. They're talking about that kinetic energy of the truck is same. Or in that case, it was also stated in the question, right? Truck uphill at a constant speed. So if it's, I mean, according to the equation for kinetic energy, it was half mv square. If velocity is constant, kinetic energy will also be constant. But if you're talking about the winch, yes, for the winch, the velocity will decrease. For the winch, kinetic energy is getting converted to GPE. So in that case, for the winch, kinetic energy would decrease, GPE would increase. But over here, they are moving with constant speed. Constant speed, the velocity is not decreasing. Even for the winch also, if you're talking about, the winch was also said to move with the constant speed. They were both moving with constant speed. So if speed is conserved or speed is equal, that means your kinetic energy will also be same, because mass is not also changing here, right? Without change in mass, without change in velocity, why would the kinetic energy different? Why would the kinetic energy decrease? Is this clear?
So the truck doesn't follow the whole once as GPE increases, kinetic energy doesn't decrease because it's moving at a constant speed.
Yes, GP increases because of the increase in height. In most cases, this kinetic energy was supposed to be converted to GPE, but over here, the kinetic energy doesn't decrease in this entire conversion because constantly I'm providing energy with that, what is that, engine. Right? If this situation was not have an engine, if the situation didn't have that engine, in that case, the kinetic energy will get converted to GPE, but I'm constantly providing energy from the engine to this winch, right? That's why the kinetic energy is also conserved. Whatever amount of kinetic energy is used to convert into GPE, that amount of kinetic energy is again refilled using that chemical energy from the fuel.
Okay, miss, it's clear. Thank you.
Amra, do you have any problem from question 3?
No, miss.
Okay, then if you move on to your question 4, this one says that a teacher investigates the counter rate detected from a radioactive source. State one source of background radiation. This is a repeated question. Amna, can you please state one source of background radiation?
Food.
Food. That's the most easiest one. Anything else? I mean, this is accepted, but anything else?
The cosmic rays,
Right. Cosmic rays and
some uranium rocks.
yes, not exactly, to be honest. I cannot say uranium rocks because how often will I get a uranium rock in my garden, right? So that's not that much common. So you can say that radioactive materials in the environment, right? I cannot say specifically uranium rocks because these are expensive. If I'm going to get uranium rocks this much often, I would get rich in one day, but we don't get that. So that's why you can say that, maybe radioactive materials in the environment. That's the easiest way. So in that case, you can write food, you can use sun, you can use cosmic ray, anything. I'm just going to give you guys the list, okay? And then again, radioactive materials. In environment. Okay, anything you can write because they're anyway giving you only 1 mark. Now again, after this, they are saying they describe how the teacher could measure the count rate from a radioactive source and correct the count rate for the background radiation. Over here in the previous question, I already understood that even without a source, for example, in my home, right, I do not have any, I'm not supposed to have any radioactive material at my home. But even if I use a GM tube, that is a gigamolar tube, even if I use that gigamolar tube over here in my home, I would still be getting some count rate for that GM tube. Why would that GM tube will give me any count rate at my home? Is that a technical error? No, that's not a technical error because everywhere, even because of electricity, for fruits, for buildings, everywhere, I am constantly getting radioactive sources. Even from my Wi-Fi signal also, I'm receiving radioactive atoms, right? Or radioactive particles. In that case, these are the particles or these are the reading that you get from background radiation. The problem is when you carry on to find out the rate, to find out the activity for a specific, maybe a specific source, right? In that case, when you are trying to find out that how much activity does that radioactive material will have, or how much activity does that radioactive source will have, in that case, again, I'm doing the same calculation, but problem is background radiation would still be there. So first thing I have to do is that I have to take my, I have to use my GM tube and I have to use my GM tube and take a reading without any source. That will be my background radiation. And after that, I'll again use the same GM tube and obviously calibrate it to 0 and again take the reading with the source this time. For the second reading that I'm taking with the source, that is not just the source. This is source plus the background radiation. And again, the previous one was only for background radiation. So if I only eliminated the first reading from the second reading, the background radiation cancels out and I'll be only left up with the reading for the source. Is this clear? Any problem from this question?
No, miss.
This is again a repeated question. Okay, that means I'm going to write that using a GM tube, I will take the reading without a source to get the value for my background radiation. One minute to get using the GM tube. Calibrate means then obviously you will make the make the GM tube go back to the zero reading and then start to take the reading again, right? So we should always use that in order to, or we should always calibrate any kind of this type of devices to avoid zero error. So I'm going to write that then calibrate. Then eliminate the first reading from the second reading to get, then eliminate the first reading from the second reading to get the radioactivity or count rate for the radioactive source. For this kind of repetitive descriptive questions, you do not actually, need to change the mark scheme points. They will always have the same mark scheme point. So, you can use these answers as a sample, maybe memorize it or try to list down all the repeated questions as we will do more question papers from now on. So try to list down this kind of question papers that I'm going to give you guys that, okay, from this paper, these are the repeated questions. Maybe write down these answers in a different file and then before the exams go through this. Because even if I'm going to use the for the mocks or for the main exam, they would change the scenario or we would change the scenario, but I cannot change the mark scheme word, right? So the description will always be similar. If you want to memorize, you can memorize them. If you cannot memorize them, then you can at least go over the samples a few times to get the idea how to arrange this mark scheme point. Over here, the mark scheme point was that take the reading only with the source, so only without any source first. Then you have to calibrate the GM tube to avoid having any zero error, and again take reading with source, and then eliminate the first reading from the second reading, that is a 4 mark, and that will give you the final count rate for the radioactive source only. Is there any problem so far?
No, miss.
No problems with.
Okay, if there is no problem, then if you move forward.
Miss, can you please post this? Like, I have to cast the written version after class.
In the classroom.
Classroom or WhatsApp, anything is fine.
Yeah, I'll post this in WhatsApp, but I'm not sure about the classroom. I'm really sorry. I'll upload that by
It's
tomorrow
okay.
in the classroom.
Okay.
Okay, then now if you move on to part B, the teacher places a piece of lead sheet between the radioactive source and a radiation detector. Okay, So between the radioactive source and the detector, I'm now placing a lead sheet, right? You should remember that from radioactive source, 3 types of particles come out, right? Alpha, beta, and gamma, right? Alpha can be stopped by a paper, like can be blocked by using a paper. Gamma can be blocked using an aluminium sheet, not block. Okay, like aluminium sheet is enough to stop them. And gamma have to be prevented using lead blocks, because gamma is very powerful. That's why they have to be blocked, or they have to be prevented from moving forward using lead blocks. Now over here, the lead sheet obviously is a precaution for the gamma radiation, I think, right? If you move forward, they are saying the teacher determines the correct count rate. Corrected count rate means that they have eliminated the background radiation for the radioactive source 3 times and calculates the mean. They repeat this process using using different thickness of lead sheet. The table shows their results. One thing to understand, that maybe they're leading us to some experimental question here, right? Over here, what are the constant variables they have kept? The constant variables is what? Count rate, reading, source, 3 times. They haven't explained any constant variables here, but I can see the independent variable here. Independent variable is the thickness of the lead sheet. This is your independent variable, because I can change this without changing any other quantities in the equation, right? I can directly change this. So this is your independent variable. After this, because of this independent variable, what will get affected? The count rate from the radioactive source. So the corrected count rate over here is your dependent variable. Because if I'm using very thick lead sheet, that means they will block more and more of the gamma radiations, alpha and beta. And obviously then the detector will not receive much of the radioactive particles. And obviously in that case will give you a very smaller amount of what is this? Count rate value, right? So this is it. And also, in order to make this experiment fair and accurate, they also repeated the experiment. This repetition and calculating mean increases the accuracy of your data, increases the reliability of your data. So we can say that increases accuracy and reliability. I do not know what they will ask in the next question, but these are the things that you should come, or you should think whenever you're doing this type of questions. So increases accuracy and reliability. Reliability. Okay. Now this is the chart they have given. We need to calculate the mean for this missing box, I think. How would you calculate the mean? First data, second data, third data. Add them, divided by 2. So you have to obviously show the working, as they're giving you 3 marks for it. So mean is going to be 141, 154, and 148, everything with 3. How much do you get for this?
147.67, 148.
Yes. Why did you choose to keep your answer as 148?
Because all the answers are given within 2 or 3 significant figures.
Right. All the answers are given in 2. This is like the thickness is given in 2 significant figures, and these are given in 3 significant figures. Since all the mean values are given in 3 significant figures, so 3 or 2, in that case, I'll also try to keep my answer in 3 significant figures. So this is 148. Okay, then after this, they're saying that now you have to plot a graph, counter it against thickness, and we have to draw the curve of best fit, right? Okay. For this kind of cases, again, you have to use 70% of the given space. The space they have given you, I have to use 70% of the given space. Now, I am going to take help from my other screen to focus on the readings. Like I'm actually taking this readings. This one will be on the y-axis, and this one will be on the x-axis. Okay, so I have values from 0, 2, 4, 6, 8, 10. In that case, I will take, if I want to take like this, 2, 4, 6, 8, 10, then I will not be using the 70% of the area. So I have to take 2, 4, 6, 8, 10. Then I'm using 70% of the area, right? And the next data where the mean value on the y-axis, which is 484. These are quite very big values, right? If you can understand. Over here also I got 148. This is a very big value. A very big value means that how will I possibly fit in 400, 100 on that small y-axis? That means this time I'm not supposed to start the y-axis with 0. Maybe I can start the y-axis with I can start it with 0, but over here I'll write, okay, this is your 100. One thing to understand, what is the maximum value that they gave you? 484. That means I have to fit 500 on my y-axis, till 500 on my y-axis. This is 100, 200, 300, and 400, and 500 would also fix there, right? So for that, what was the first data? It was 484, right? So 484 I cannot fit in, but I can approximately fit in 480, which is here, right? 480. 480 was at 2, so this is where a point will be. The next data was 356. 356 I cannot plot exactly on this graph because I don't have much space, but I can use 370 approximately. So 370 is here. And then again, the next one is 238. This is 240 in that case. I can fit in 240 over here. So 240 was here. Next one was your 148, which is 150. Yeah, 150 in that case. 150 is here. And final one was 115. So this is the second last one. So this is the last one, 118. 118 means this, so 115. This is then approximately 120, right? So 120 is this one. So we have plotted the graph and obviously labeled the x-axis and y-axis. On the x-axis, you have count rate in becquerel. And on the y-axis, you have, sorry, 1 minute, please. I think Amna by mistake left the meet. Wait 1 minute, please. Okay, as I was explaining that now again on the y-axis, I have to write thickness of lead in millimeter. And lastly, for part 2, you just have to plot a smooth curve over here. I mean, you're supposed to plot a much more smoother curve, but this one will also run. I mean, just connect it over here. Okay, this is how the graph is supposed to be. Now, again, after this, this is it for the curve. After this, they're saying that when there is not a sheet of lead between the radioactive source and the radiation detected, the mean count rate was 484. Use the graph to determine the thickness of lead needed to reduce the mean count rate by 25%. They're not asking for 50% decrease. They're asking for 25% decrease. 25% decrease means how much becquerel will be. We'll have to find out that. So I'll consider that as activity. Wait 1 minute. The axes were labeled wrong. This was the count rate, right? And this was your thickness in millimeter. Sorry, this was the count rate. Okay, now in this case, over here, if I want to find out 25% of that initial activity, so I'll work out with this as 25, sorry, 25% means 25 over 100 with 484. How much is this?
121.
121. That means actually I should have used 75% because 25% was used up, right? That means for that 121 was already used up. So how much will be left after the 121 activity is used up? So you can calculate that as 484 minus 121 also, but this will be an easier process. Then okay, 25% is used up, 75% is left. So what was the amount for that 75% of 484? What is this amount?
363.
363 in that case, 363 becquerel. So for that 363, I can understand that obviously when you're taking readings from the graph, you should always show that on the graph with the broken lines. 363 is somewhere over here, right in between the 33.6 and 37. This one kind of matches with your line on this part. This is going to be 3.9, right? Because this is 3, each line over here indicates 0.2 seconds. So this is 3.9, somewhere between 3.8 and 3.4. So this is 3.9 in that case. So we'll write, wait 1 minute. 363, right? Actually, the graph was a little bit wrong. The graph over here, the original data was exactly, sorry, 1 minute. The graph over here was actually wrong. 484 was for 0 reading, not for 2 reading. Okay, 484 was supposed to be over here. And then your next reading, which was actually 356. Okay, sorry, made a mistake. 356 was for 2 reading. And then again, this one, which is your 238, that was for 4. And then your 1.5 or 150 was for 6. And lastly was your 120 approximately, that was for 8. And then again, the last one was 88 only. For 88, you can write somewhere over here. And then that should give you a correct graph. You should not overlap the graph like a graph like I did, but that's the best I can draw at this point. Okay, but the graph is supposed to have a smooth shape like this. I hope you guys understood the mistake I did. And now if you start taking the reading for 363, right? 363 is over here, and this is very close to 2 in that case, right? 363. Yeah, but it is not exactly at 2, as you can see. This is in between the 1.8 and 2. That means this is your 1.9 in that case. So you can accept the value for time over here as 1.9. So you can say, okay, this is your 1.9 that you took from the graph reading. Again, for this next part, it says the radioactive source emits one type of radiation. Explain which type of radiation this radioactive source emits. Because in this case, even after using lead, right? Even after using lead sheet, the lead sheet was not able to block it. Understand that lead is the maximum preventing material that you can use. Lead will block everything above them. Paper will block only alpha. Aluminium sheet will block beta and alpha. Lead will block every one of them. But over here, since thin sheets of lead sheets is not able to block this entire radiation, that means obviously this is not alpha and beta, this is gamma. We need much more thicker sheet of lead. So over here, that was your hint. Since even after using sheets of lead, I was still receiving count rate values. That means obviously this is a gamma, because beta and alpha will be totally absorbed by the lead. And only gamma can penetrate through thin lead sheets. If you're using very large or very thick lead sheets, they would also be absorbed by lead. But since you're using very thin lead sheet, that's why the gamma can penetrate through them. So you can see that again over here, this is gamma. As they can penetrate, through 3 thin lead sheets. Is this clear? Any questions from this question 4?
It's clear, miss.
No,
Okay.
miss.
If this is clear, now actually we need to stop the class. 1 minute. Okay, now in the last class we completed up to question 4, so we're going to start with question 5. In question 5, it says that the graph shows how the thinking distance and braking distance vary with the speed of your car. So this is for the braking distance and this is for the thinking distance. We can understand that obviously is if you're trying to draw a distance time graph for braking distance, for thinking distance, your object is moving with constant velocity, right? Because during the thinking section, the driver is still thinking, the driver is still processing that what to do about the obstacle in front of them, right? They didn't make the decision before or during this thinking distance, right? This is the time or this is the distance that the driver is passing while they are taking any decision about what they should do about the obstacle they have in front of them. So for this thinking distance, they have not applied the brakes yet. That's why for the entire thinking distance, you will see that the brakes, whatever the velocity was they were traveling with, the velocity will continue to have the same value. Okay, in order to have constant velocity for distance time graph, the gradient should be a straight slant line, right? The gradient should be constant because for distance time graph, you get the velocity as the gradient for your graph. In order to get a constant gradient, the shape of your graph is a straight slant line. Another thing, if you understand, over here for the braking distance, what happened? In case of braking distance, your car has now applied the brakes. If your car has now applied the brakes, that means eventually your car will decelerate, right? Eventually your velocity will decrease. During the braking section, this is how it works. The car decelerate. Decelerate means that the velocity will decrease, right? So in order to find out the decreasing velocity, which is, by the way, the gradient for your distance time graph, in order to indicate decreasing gradient, I have to represent a graph with eventually maybe smaller gradient, right? As you can see. Not exactly smaller gradient. Over here, I'm going to get the opposite actually. What you can see is that initially over here, your graph has a less steep gradient, right? Less steep gradient means what? At this point, you have a smaller gradient. For the distance time graph, the gradient is speed. And, oh wait, sorry. The x-axis over here is your speed, right? There's actually a difference over here. The x-axis is speed, not time. That means I cannot actually find out the gradient over here. If I want to find out the gradient, that is what? This time the gradient will be 10. So the gradient will be time, right? Again, you have to understand this, that initially when you haven't applied the brake for a longer time, your speed was still traveling at a larger speed, right? This is how the equation is. T 1 over v multiplied with d, right? What you can understand from this equation is that time and velocity are inversely proportional, where time and distance are directly proportional. So in order to find out for the initial case, when the velocity was very high, according to this equation, or not exactly according to this equation, since over here now the y-axis have velocity and the x-axis have distance, I should write down the equation as v is equals to 1 over t multiplied with d plus 0. This is exactly in the form of y is equals to mx plus c. The reason to write your equation in this format, y is equals to, v is equals to 1 over t multiplied with d plus 0, so that I can resemble this equation with the y is equals to mx plus c format. And from there, I can understand that velocity is inversely proportional to time, right? So under this reference, if I want to express that, okay, over here, the gradient is less steep, and the gradient is more steep, because for the gradient for distance speed graph, the gradient is always time. So in that case, for a larger speed, when the brakes have been applied for a very small amount of time, during that small time the object will be still moving with a larger velocity. For a larger velocity, your time taken to travel the distance will be very small. But now if your brakes have been applied for a longer time means now maybe the brakes have been applied maybe 5 to 10 minutes before. But this time, by that 5 to 10 minutes after, your velocity will decrease. If velocity decreases, obviously as velocity and time are inversely proportional, so time in that case will become more steeper, right? So that's why you can see this is less steeper and this is more steeper. So over here, the gradient actually gives you time, not distance. So gradient gives you time, not the calculation for your speed. In most of the cases, obviously we work with distance and speed, distance and time. But this was an exceptional, because over here they have given you speed on the x-axis rather than time. Now, if you move on to your graphs, not the actual question paper. So far, I was just analyzing the shape of the two curves, right? Now, if you move on to your question, Which of these does not affect thinking distance? Alcohol consumption by the driver. This will affect the thinking distance, right? Alcohol consumption obviously makes your mind tired. If your mind is tired, then obviously it will take a longer time to think for an obstacle. And then condition of the road. Condition of the road would affect the braking distance. Condition of the road is not affecting the, anything that is related to the car, right? So that is your final answer. Condition to the road is your final answer. Condition to the road would not affect your final answer. But other than that, speed of the car would also affect the thinking distance, because if you were originally traveling with a larger speed, if you have an obstacle in front of you, right, obviously you'll just maintain that large speed to travel for the entire thinking distance. That means if you're maintaining a large speed to travel for the entire thinking distance section, eventually you will travel a longer distance. So speed of the car before they saw an obstacle and during the thinking distance time, during the thinking distance duration, if the speed of the car is very high, that will obviously modify the value of your thinking distance and everything. So this also affects the thinking distance. And lastly, tiredness of the driver. As I've already stated, alcohol consumption was also the problem, because alcohol makes drivers tired, right? If the driver is tired, that means obviously the driver cannot carry out the journey properly or cannot create instant decisions properly. That's why this will also be a correct answer. Any option which would not give any effect on the thinking distance is your option B, that is condition to the road. That would be one of the effects for your braking distance, but not for thinking distance. And again, next one, which of these would increase the braking distance of the car? Faster reaction time of driver. Braking distance, they're talking about that what will increase the braking distance. Faster reaction time means that thinking distance would decrease. Right. This time, if the driver is moving with a faster reaction, or if the driver has a faster reaction time, that means obviously the driver will travel a smaller thinking distance. After a smaller thinking distance, it will quickly apply the brake, and the car would travel eventually a smaller stopping distance or braking distance. So obviously, a faster reaction time would not increase the braking distance. Ice on road, obviously, they makes the glass, say, road slippery. For that slippery cases, the cars would slide over each other or can slide on road. Because of that sliding on road, obviously they will exert what? Because of sliding on road, at that point the car does not have any control onto the car, right? Say the driver does not have any control to the car. So that is an important effect for braking distance, but I cannot stop the braking in distance at that time. If a car is skidding, if a car is sliding, I cannot prevent it from doing that. So obviously skidding and sliding will eventually increase your braking distance. So option B is your correct answer. Other than that, more powerful brakes. More powerful brakes means that this time I'm going to hardly brake the car, right? Hardly brake the car means that I will instantly I can apply instantly. I can apply the brakes instantly, and the braking distance would be smaller than the usual. For more powerful brakes means that now the braking distance would decrease. It would not increase it. So this would decrease the braking distance, not increase it. And lastly, tires with some grip. Tires with some grip also again maintains friction. If you have more friction again decreases braking distance. So this is also decrease. Only option here is your option B, that ice on the road is slippery, watery, and that will increase your braking distance. Is there any problem for part A and B?
No, miss.
Okay, if there is no problem, then they are saying that determine the stopping distance of the car when the speed of the car is 20 meters per second. The stopping distance of the car when the speed of the car is 20. Whenever you're taking information from the graph, you have to always make sure that you are labeling that point on your graph paper with these broken lines. Right. So you now have how much? 38 distance in meters. So you can write that, okay, over here you have 38 meters. Determine the stopping distance of the car. Oh, they are not only asking you for the braking distance, they're asking you for the stopping distance, which is, by the way, thinking distance plus braking distance. Braking distance is this one, which is you got as 38, and thinking distance is 10 246 10.6. So this is your 10 points. Sorry, this is your 38 plus 10.6. Is it 10.6 or 16? Sorry, it's not 10.6. It's 14 and 38, right? 14 this is. So this is going to be 38 plus 14, and that is 52 meters. So you get 52 meters for your final answer. Then state the formula linking average speed, distance, and time taken. I can understand this is what V is equals to D over T. I'm just using the symbol, but you obviously have to write the equation in terms of the words they have used in the question. And now they're asking to find out the reaction time of the driver. Okay, reaction time of the driver means that exactly at. Okay, I think I made a mistake. We're supposed to draw a line at this point, right? At x equals to 20, not at 21. Sorry, 1 minute. In that case, we have (26) and 10. And this is 20, 26 and 10, right? So this 38 will get cancelled out. This is your 26 and 10. 26 and 10, the subtraction between them is going to give you, the addition between them is going to give you 36. Sorry, I made a mistake. This is 26 plus 10, and that is going to be 36. Okay, now after this, if they are asking you to find out calculate the reaction time of the driver, but the reaction time, you have to understand that for speed of 20, your distance was 10 meters per second, 10 meters, right? So in order to find out the reaction time, I'm only going to focus on the calculative parts of your thinking distance. In order, if I want to find out the reaction time of the driver, that means I'll obviously have to use information when the car was moving with constant velocity for the thinking distance region. That means over here, your distance is going to be 26 divided by 10 seconds. Was it 10 seconds? Sorry, 26 divided by 20. Right, 1 minute. What are they asking? Determine the reaction time of the driver of the car. Now, if I'm using 20, (10) and 30, this is how I'm supposed to use the equation. D over here is 10 meter, and D by V it was, right? Velocity was 20 meters per second. And that will be 0.5 second. And that is your final answer. The reaction time for the driver of the car. And then again, finally, they are asking that calculate the mean braking acceleration of the car as it brakes to a stop from its initial speed of 30 meters per second. Initial speed of 30 meters per second means what? Exactly the final point, your velocity is 0. Right, and 30 meters per second means that they're talking about this one. From the graph, you can identify what time it was given for this 30-meter distance travel, or 30-meter 30-meter distance travel, which is approximately 23, right? 23 meters per second. So you got the velocity, and state the mean calculated acceleration of the car as it brakes to stop from a initial speed of 30 meters per second. Okay, the initial speed was 30 meters per second. That means obviously after all the thinking distance, it would have only traveled the 30 meters per second. And again, after that, after applying the brake, it will start decelerating. Mean acceleration of the car as it travels to find the... Yeah, I think this is it actually. There's nothing else I can explain. Over here, they were talking about the value for your, the value for the graph, where over here the object was moving with constant velocity, right? I think it was written over here. Braking acceleration of the car as it travels from initial speed of 30 meters per second. This time they're asking about braking acceleration, but they have used the term speed. right? They're asking of the car as it brakes to stop from initial speed 30. So initial speed is 30, time is 0. And what will be the value for your time in this case when the velocity is 30? When the velocity is 30, time would be in that case 23, as I've already stated. So for this case, you can write that, okay, your speed is 23, distance is 26, 26 divided by 23, and so 26 divided by 23, calculate the mean acceleration. Okay, braking distance, right? At 20 meters per second, one braking distance is 26, the other braking distance is 10. So you get 36 meters of braking distance. But they are asking you, determine the reaction of the driver of the car. Determine the reaction of the driver of the car. 1 minute, please, guys. Calculate the mean braking acceleration of the car as it travels from to a stop from initial speed 30. Okay, over here I can understand that initial speed is 30, final velocity is 0. S we have to calculate, right? If I have to calculate S, they must have given me the idea about S somewhere in the maths, but I cannot find out where to use S. Determine the reaction time of the driver of the car. Okay, we did that. We did calculate the reaction time of the driver of the car. And after that, they're asking that braking acceleration. Final velocity is 0. How much distance they have traveled here? One I can see is at at 30, 26, and the other is at just 10 for that 20 meters per second. Other than that, I don't see any other value that I can use for the.
So using the graph, can't we take 53 as the distance traveled for stopping distance?
How come is it 53? Are we
Because
talking about the stopping distance here? Yeah, braking acceleration. Okay,
then we can use the v squared. Yeah, v squared equals u squared plus 2as to find acceleration,
Mm.
right?
The problem is that we don't have the value for S here. Is the S given?
But s is given in the graph, right? Like the maximum point the graph reaches is the distance traveled.
Or they're saying that calculate the mean braking acceleration of the car as it reaches to stop from the initial speed, right? So in that case, yeah, in that case, you can say that exactly at how much? 53 distance, that is the maximum acceleration or braking acceleration, right? After this, the graph will obviously come to stop. That means exactly at 53, your distance is your whatever this object was, that will come to stop. So in that case, we can write that v square u square plus 2as, and that gives you v as the value for u is 30 square plus 2. A is your, I want to find out the value for A. V is 0 square, U is 30 square, 2. A is unknown actually, that I want to find out, and S is 53. From there, you can find out the value for A. How much is this? That's 900 divided by 2 multiplied with 53. And
You
that
get
gives you,
negative
how much do you get?
negative 8.490.
Negative 8.5 in that case we can write. So this is when the value for your A is going to be negative, right? This is your braking acceleration. That means obviously object is decelerating. So I'll write negative 8.5 meters per second square. Amra, do you have any problem from this part?
No, miss.
Okay, if you do not have any problem from this part, then we will move forward. The question is about optical fibers. The optical fibers use light waves of communications. Use of this is a correct statement about this. Waves transfer energy, information, and matter. Waves do not transfer energy, information, and matter, which is wrong. Waves transfer energy without transferring information or matter. No. Waves transfer energy and information without transferring matter. D is your correct answer, right? They're saying that obviously waves will transfer energy and information, but it will never transfer the particles of the matter in order to transfer the information, right? This particle will only vibrate maybe in up and down direction or back and forth direction, but this particle would never change the position. This particle will always be fixed at its fixed position, but it will only vibrate to transfer the energy and information forward. And then lastly, we can say that a ray of light passes from air to glass optical fiber. Diagram 1 shows the path of ray of light after it has passed through the boundary between air and optical fiber. Draw the path of ray of light in the air before it has passed through the boundary. This is your refracted ray and glass ray. Draw the path of ray in air before it has passed through the air boundary. Okay. In that case, first thing I have to draw is your what is this angle? I mean, normal, right? This is a perpendicular normal. One thing I can understand that if your ray of light is very close to your normal in the glass medium, obviously glass is a more dense medium. For more dense medium, light always moves closer to the normal. That means for less dense medium, light was farther away from the medium, right? This is how the light would be for the incident ray. And this is your angle I, this is your angle R, and we can write this is my incident ray. And state the name of the wave behavior responsible for the path of the ray as path of the ray of light as it passes from air to the optical fiber. This entire thing, what is it known as? Refraction, right? Whenever this light passes from air to the optical fiber or air to the optical fiber, and because of the changing medium there is a bending in the direction, this phenomenon is known as refraction. We already know that. After this, again, they are asking that now explain the path of the ray of light as it travels through the optical fiber. We can see that over here, this is what total internal reflection, because core has a higher refractive index than air. And in this case, the angle of incidence is also greater than critical angle, right? These are the 3 points that should be written over here in order to get these 3 marks. So for the final answer, I will write that total internal reaction, so total internal reflection is occurring at every boundary. At every boundary. Because core of the glass have a higher refractive index than air. And also your angle of incidence is greater than critical angle. is greater than critical angle. Okay, now after this, is there any problem from question 6?
No, miss.
Amna, do you have any problem?
No, miss.
Okay, so in that case, if I move to this part, give the name of component Y. This is what? A variable resistor, right? A square rectangle box with this arrow in between. This is a variable resistor. So we can write, okay, we have a variable resistor here. And give a reason why component Y is included in this circuit. The resistors are always included in a circuit so that we can control the current flow in the circuit, right? So that's what it is. I mean, over here we are introducing variable resistors in this circuit so that we can control the current or change the resistance of this circuit. That will eventually control the current also, right? Yeah, we can write that. Okay, it we can change the current flow along the circuit with this, or we can change, or we can control the current. To be honest, if it was entirely a fixed resistor, then I would have stated that, okay, the amount of current flowing into the circuit is controlled, because in that case, for the fixed resistance, only a certain amount of current can enter your circuit. But in this situation, as they have introduced variable resistor, that means I can vary my resistance of the resistor. If the resistance of my resistor is getting varied, that means the resistance of my, the current of my circuit is also going to get varied. So I should write that so that we can vary the current in your circuit. So we can vary the current in the circuit. Right, this is your final answer. Now, if we move over here, maybe we're supposed to carry on with the graph shape, but let's see. The first thing they're asking, this equation, charge, current, and time, right? This is what? Just charge, current multiplied with time. And then now they're asking to find out the value of the current in the lamp when the voltage across the lamp is 10 volt. If the voltage across the lamp is 10 volt, then this is 10 value, right? 4, 6, 8, 10. If this is 10, then at this point you get here. That is 0.4. This is, I think, 0.48. This is 0.48 current. Okay. So for that 0.48 current, 10 voltage, we want to find out we just have to find out the current. We got that from the graph, 0.48 amp. And after this, now they're asking that calculate the charge transfer through the lamp in 30 seconds when the voltage across the lamp is 10 volt. And we need to give the unit for this current. Okay. So 30 seconds and 10 volt. 30 seconds and 10 volt mean that over here I have to use a Q is equals to IT. For I, we have the, how much is this? For I, 1 minute. For I, I is current, right? Current is 0.48 multiplied with 30 seconds, right? So just have to multiply them. 0.48 with 30, that is 14.4. 14.4 coulombs. And this is the coulomb unit, and you get 14.4 here. Finally, after this, they're also asking that calculate the time taken for the lamp to transfer this much amount of energy when the voltage across the lamp is 10 volt. That means time taken, right? Time taken to this. Okay. If I try to find out the value of your energy, that means we are using the equation power is equals to energy over time. From here, I just have to make time the subject of the equation. Energy is 250. Power is how much? Voltage multiplied with your current, 0.48. So you get 250, 10, 0.48, and that gives you the value as 52.1 seconds. So this is 52.1 seconds, right? So this is it. Is there any problem so far?
No, miss.
Okay, then after this, if we continue, now they're saying the student disconnects the cell and reconnects it with its terminal reversed. Now they have reversed the terminal, and you need to complete that graph over there. For this is what this is. I mean, in this situation, this is how the graph is supposed to look, right? Exactly the opposite shape that we create, right? This is how the graph is supposed to look. This is how the shape is supposed to look for this graph. Now, after this, they are asking now in this orientation, what do we have? We have the student replaces the filament lamp with a light emitting diode and replaces the cell with an alternating current. Understand that alternating current is present over here. Alternating current means that current direction of the current is going to change in every second, right? Or every certain period of time. And LED is a diode. Diode only allows current to pass through them in one direction, not in two directions. That is a problem over here. Since we're applying AC current here, that means only when your current is maybe flowing in this direction, your component Y will light up or your entire circuit will work. When your current is passing in this direction, your entire current will will have the will face the maximum resistance and entirely block the current, right? So they are seeing that as shown in the diagram. The student also removes the ammeter and voltmeter from the circuit. In this circuit, no ammeter and voltmeter is also connected. They are saying that explain why the LED flashes on and off in this circuit. That's because of LED only allows light to pass through them or current to pass through them in only in one direction. So when AC is lighting up, LED is lighting up, that means AC current is passing through the correct direction where the resistance is low, so the LED can light up. And when the LED will light off, when the LED will not turn on, when the LED turns off, that means now because of the AC current, the direction of the current is reversed automatically, and now current is flowing in the opposite direction, which has a high resistance. For high resistance, the diode will not allow to pass through them without current. Obviously, the LED cannot turn on, right? It will remain turned off. So that's why after every period of time, when the direction of the AC current changes its direction, the LED turns on and off, like it creates a flashes in that kind of shape. Okay, so then if we start explain why LED flashes on and off in this circuit, we can say that over here, current, I mean, for AC current, or we can say that AC current causes the current to change its direction after after a certain period of time, whereas LED can only allow current in one direction. So LED lights up when current flows in the correct direction with lower resistance, and LED will not light up when the current reverses its direction where the resistance is high. As LED can only allow current to flow in one direction, so LED lights up when current. So LED lights up when current can flow in correct direction with lower resistance. And turns off when reverse directions with high resistance. I know they're giving you only 2 marks over here, but I have given you the maximum number of explanation that you can include in this type of questions. Right? They might ask you this type of questions for 2 mark. They might ask you also to this kind of questions for 5 marks. So I have given you the maximum maximum mark scheme point for this type of questions. Is there any problem from this question 7?
No, miss.
Okay, then we'll move on to question 8. Okay, now in question 8, it says that explain which of the stars have the highest surface temperature. Okay. For this highest surface temperature, mass in solar masses, that is not a problem. But you have to understand that for the highest, wait 1 minute. Information is given, the solar masses is given, and explain which of the stars have the highest surface temperature. In these cases, blue, white, yellow, white, red, and blue. Right, out of this, only blue would indicate the high surface temperature. Right, it doesn't have anything to do with their solar masses. It is only related to the color, because color depends on the surface temperature. So any star which has a blue color appearance, they have the high surface temperature. So that means a regal over here is your any astronomical body with the high surface temperature. So we can write that, okay, over here, regal as color depends on surface temperature. Okay. Now, after this, if we move to this one, discuss the evolutions of stars, Regal and Sirius. Okay, this is a repeated question. You can memorize the definitions for this type of questions. For the evolutions of the star Regal and Sirius, you have to say that both stars begin in a nebula, and both were protostars, and both stars are in the main sequence stars. And now, if you want to differentiate them, that these are the similarities for them. If you want to differentiate that what are the specific points for Regal and what are the specific points for Sirius, we can say that Regal has a maximum mass, right? Yeah, Regal has higher mass star compared to your Sirius. It has a lower mass star, and then again Regal has a larger surface temperature compared to your Sirius Sirius's surface temperature. Regal, now at this point, Regal is actually at the end of your main sequence star. After the end of your main sequence star, Regal will obviously turn or will become a red supergiant, and whereas your Sirius over here will become a red giant, right? It was in a white dwarf, it was in a end of your it was at the end of your main sequence also, but with a lower surface temperature. For the lower surface temperature, it will enter the white dwarf, or it might become a white dwarf or red giant, but for Regal it will become a red supergiant. These are the evolutions for Regal and Sirius in all the cases, from the start to the end. So we can say that for they both start as nebula, or we can say they both were protostars and start in a nebula and are main sequence stars. Now these were the similarities. Now for the differences, it is going to be that Regal A red giant, right? And writing all these things are enough over here. Okay, now this is a repetitive question, so that means you can memorize this answer also to find to write the definitions for the evolutions of your star Regals and star Sirius. Any problems so far from question 8?
No, miss.
Okay, if there is no problem, then we'll move on to question 9 quickly. Determine the amplitude of the wavelength measuring with the ruler. I mean, I cannot actually measure this, but this is how, if in your copy you're supposed to measure this, right? First thing, I'm supposed to measure a horizontal, draw a horizontal line, and this one, from the horizontal line to the maximum displacement, that will give you the value for your amplitude. Now, whatever the value for your amplitude is, like you have to take that measurement from your hard copy, because from this type of file I cannot measure it. So I'll consider any value for amplitude. I'll consider that as like, that's not even 1 centimeter, right? So I'll consider that is at 0.7 centimeter. This is just a random value. And determine the wavelength of the wave by measuring from the ruler. Again, same thing, from one crest to another crest. I'm considering that is my one wavelength. So for one wavelength, this is approximately how much? 1.3 or something, right? Yeah, 1.3 centimeters. I do not know. You have to take the measurement from the diagram, but this is how you will take the measurement from this top point to this top point, right? Whatever the value that you get. Name the part of the electromagnetic spectrum which has a lower frequency than microwave. Lower frequency than microwave means that what is this? Radio wave, right? Because after microwave, if you go down that chart, obviously your frequencies increase, right? That means after microwave, you have infrared wave that will have a higher frequency but lower wavelength. So lower wavelength is only one wave, that is your radio wave. So we can say, okay, this is your radio waves. And then after this, microwaves travel with a speed of this much in air. Microwave have a wavelength of this much. This is what, 2.7 into 10 power minus 2 meter, and calculate the frequency. In order to find out the frequency, it will be just be f over, say, v over lambda. For v, it will be 3 into 10 to the power 8 divided by 2.7 10 to the power of minus 2. From there, if you calculate it, you are going to end up with getting 1.1 to 10 to the power of 10 hertz. So 1.1 into 10 power 10 hertz. And that is your final answer. By the way, you're using the equation this, right? V is equals to f lambda. From there, I just rearranged and make frequency the subject of the equation. And for this part, I think this is a descriptive part or something. So far, is there any problem from this part A and B?
No, miss.
Okay, now for this part, they're saying that the student uses a microwave source and a receiver to investigate the microwaves. Photograph shows how the student sets up the apparatus, analog meter, receiver, microwave source, and this ruler. And then this is the analog meter and everything. We need to read this over here from this diagram. I can understand that if this is 60, then this is going to be 70, right? This is 1 unit before 70, so this is going to be 68 then. Exactly 68. So we get, okay, 68 arbitrary units, whatever the unit for this machine was on photograph 2. And this is how the graph gives you the final shape. Now the student concludes that the meter reading is inversely proportional to the distance between the microwave source and the receiver. To be inversely proportional, meter reading multiplied with distance is a constant. And comment on the student's conclusion. You should use data from the graph in your answer. Okay. Now in this equation, we can say that 1 minute. We do have a non-linear graph, right? But I cannot exactly say if this is inversely proportional or not. If this was inversely proportional, then my meter readings and distance, the product of them should always be a constant value. So for example, if I use this one, maybe a very easy coordinate I'm looking for. Let's take this one. This is a quite easy coordinate. If this is 15, then this is 10. So this is going to be 11, right? If this is 11, 11 with 80, 80 with 11, that gives you 80 with 11. That gives you 880. But then again, the next easy coordinate that I'm looking for is maybe this one, right? This is your 22.5 with 20. So 20 multiplied with 22.5 is 20 with 22.5, and that is 450. From this 2 point, I can understand that your product for the distance and meter reading is not constant, right? If they were indeed inversely proportional, that means doesn't matter whatever point you are working with, their product should be always same. Everywhere you're supposed to get 880 or 880. But in this examples over here, you can see that no, they are not exactly same, right? If their product of the distance and meter reading are not giving a constant value for different units, that means obviously you have to say that no, in this entire graph, the relationship is not inversely proportional, right? You have obviously taken information from the graph also. Is there any problem understanding this type of questions?
No, miss.
Okay, in that case, I'm going to first read down the statement that okay, relationship is not inversely proportional. Inversely proportional. And why we're saying this, the relationship is not inversely proportional, because for data 1, we're going to calculate this twice. Okay, for data 1, we have 80 multiplied with 11, that's 80 multiplied with 11, that is 880. And for data 2, we have how much? 20 with 22.5, that is going to be 450, right? So from this two value, we can say that this two given data, or this two data doesn't give you the, doesn't satisfy the equation meter reading multiplied with distance equals to constant. So our conclusion is true, right? Or we can say that these data are constant, right? So that on that basis, we can say that obviously they are not directly proportional. Is this clear? Any problems so far? Wait 1 minute, please. Uh, Amna, any problems so far from this question 9?
No, miss.
Okay, if there is no question, then if we move on to this one. A student pours a known volume of hot water into a meal container, and so into a metal container, and they place a metal container in an insulated plastic cup. Okay, so metal container is inside the insulated plastic cup, containing an equal volume of cold water. So the plastic cup again contains an equal volume of cold water. The student uses the temperature probes to measure the temperature of both the water of the metal container and the water in the plastic cup. I can understand that metal container contains hot water, right? That hot water will easily lose its energy since metal is a good conductor of heat and energy. But for the plastic cup, obviously it will accept the heat that the metal container is releasing, but the plastic cup will not radiate the heat outside the plastic cup. So for the water in the plastic cup, they will only accept the energy. They will only increase in temperature, but for them, they will not actually decrease the temperature, right? This is how the interchange is happening because plastic cups are insulators of heat. Now, the hot water was initially at a temperature of 70 and cold water is initially at a temperature of 5. On the axis case, the temperature of the hot water and the temperature of the cold water vary with time. Obviously, what happens for the hot water, it will decrease from 70, and for the cold water, it will increase from 70, right? You have to understand that for the hot water, initially, the decrease, the rate of transfer, the rate of energy transfer will be very high because the larger the difference in between the temperature, the faster the energy will flow. So this is a very steep graph. They will, meet at some point in the middle in order to become at equilibrium, yeah, at thermal equilibrium. Meet at equilibrium. Thermal equilibrium means that they will eventually stop changing the energies when once the temperature for the cold water in the metal cup and the hot water, hot water in the metal cup and cold water in the plastic cup reach a same temperature. Right, so this is your thermal equilibrium. Now, I might not know what is the value for this, but this is your thermal equilibrium theta degrees. Now, after this, we need to explain why the temperature of the hot water and the cold water change, and you have to refer to different types of thermal energy transfer in your answer. One thing to understand that, thermal energy is always transferred from hot to cold water by conduction through the metal, which is a good conductor for energy, right? And the energy transfer does not stop until the thermal equilibrium is reached. And then you can see that some energy is lost to the surrounding by convection or by convection or evaporation, and no energy is lost or no energy is transferred no energy is transferred to the surrounding through the insulated plastic cup because that is a insulator, right? Insulator does not conduct heat or any type of energy. That is your final answer. So for the final answer, let's write this down that thermal energy, we should also say that the hot and water loses energy and the cold water gains it. As thermal energy flows from hot to cold water, and then you can say by conduction. By conduction through metal, which is a conductor for heat. For heat. And finally, we'll write that energy will continue to transfer until they reach a thermal equilibrium. Thermal equilibrium. Okay. Now, after this, they are saying that explain how placing a lead. Wait, is there any problem from this part?
No, miss.
Amra, do you have any question?
No, miss.
Okay, now they're asking to explain how placing a lid on the plastic cup would affect the results. one thing you should understand that in the like opening for the metal cup or plastic cup, both were open. That means some convection currents can happen over here. Because of that convection current, obviously heat or energy will be lost to the surrounding. Now if I'm going to place a lid on top of this plastic cup, that means this kind of totally blocks all the energy inside the plastic cup, inside the metal cup, all inside the metal cup also, right? So placing a lid means that now you are preventing convection to happen. If you are preventing convection to happen, that means no energy will be lost from the inside of the cups to the surrounding, and this time thermal equilibrium will be reached at a smaller time, right? Or the equilibrium temperature, but at a smaller time. Yeah, it will actually be at a smaller time, and also the thermal equilibrium temperature will be higher than the actual value that you got for the situation when there was no lead on the cups, right? Because in these cases what happens that some of the energy was lost to the surroundings, and after losing something to the surrounding, they will reach a thermal equilibrium, which is a constant temperature for both of the waters in the metal and plastic cup. But if the entire energy is restored, that means nothing gets lost to the surrounding. This time obviously you'll get the maximum temperature for the thermal equilibrium. That is one change again. So we're going to write down the changes that energy transfer by convection is prevented by using the lead. Energy transfer by convection is prevented by using lead. Is prevented by using a lead. At higher temperature. Okay, now this is your question 10 then. Now lastly for question 8, actually question 8 is not that much difficult to understand. Question is 8 is about pressure and particles, right? What happens over here is that when you exert pressure on the walls of the container, how would that increase the pressure, right? Explain how atoms exert pressure on the walls of the container, because obviously atoms are moving randomly. They collide with the container walls very frequently, exerting more force. And according to the equation, P is equals to F over A. For a larger force, you always get a larger pressure since they are directly proportional. And then again, in the next question, maybe they're asking that explain how the pressure of the gas in the container decreases as the temperature decreases, because this is according to your pressure law. If the temperature decreases, the particles have less kinetic energy, so they will now move less frequently. Less movement means they will collide with the container walls less frequently, exerting less force and eventually smaller pressure, right? And for part 1 and 2, these are just descriptions. And for part 3, for part B over here, this is the equation that you have to use, right? Maybe with kinetic energies and half mv squared, this kind of cases. Just skip question B. I will do that in tomorrow's class, okay? Because I'm not actually feeling well to continue the class. I'm really sorry. But we will complete this option 11 in the next class with your homework in our tomorrow's class, and just try to write down the answer for 11 A1 and A2, because for A1 and A2 you just have to write down the descriptions and nothing else. So I think you guys will be able to write down the answers for A1 and A2, But even if you can't, we'll obviously do that in the next class.